Is this the future of drivetrains? Can this simple loop of carbon cords derail the mountain bike status quo? We're here at Gates to find out if it's the end time for chains on mountain bikes. What do we have on mountain bikes at the moment? We've got a derailleur, we've mostly got one by, and we've got this chain moving up and down the cassette. And that's okay, isn't it? Sort of. Before confirming the death of a drivetrain, what is the status quo? Well, skipping to the rear mech first, and skipping is the right word, as whilst they've evolved a lot, effectively, all derailleurs are trying to do the same thing, and the name is the key. They're trying to derail the chain, which is kind of counterintuitive because we need a direct connection between the chain and those drive cogs to make sure that the drive is, as it should be, consistent all the time. But I think we need to talk about the chain because that's where things get a little bit confusing. Okay, so what's a chain made up of? Well, very briefly, we've got some outer plates, we've got some inner plates. Then we've got a roller, and through the middle, we've got a pin. Gets interesting with a roller, because effectively that's a bearing, and it's open to all the elements. That's not great. Even if we use the best lube on the planet, well, A, you can get little bits of dirt and detritus and grit stuck in there. The other problem is that if you're riding in very arduous conditions, that lube can wear out or wash off. Then what have we got? Well, we've effectively got an open bearing that's carrying all our load from the crankset to the cassette. Kind of gets worse because actually when that roller wears, well, it starts to wear other parts of the drivetrain out. And actually it sort of gets worse still because opposed to keeping that chain stable and effectively this chain line really straight, we're actually trying to put a really big side load on the chain. So if you look at the back of the bike, when you're in the biggest cog or you're in the smallest cog, you've got a huge angle. So you're actually opening up that roller to let more grit and more grime get in there. It's a wear item, but we have got the drivetrain that we have for various reasons of shifting compatibility and how bikes have been designed. But it feels like with the bikes we've got at the moment, it's time for a change. It's time for something better. This is where Gates come in. So, can this be the future? Well, just at first glance, it doesn't have 118 or so little links and little pivots that are open to all elements. It's just, well, a one-piece design. There's actually a lot going on with this. We've got a toothed belt here. We've got a special belt sprockets. And whilst it does look sort of rubbery, it's not. It's polyurethane. We've got a special coating here. And if I did have X-ray vision, I'd be able to see that inside we've got some carbon. And if you've watched any of our videos on carbon fibre, you'll know that how it's laid up and how carbon fibre is used is really important. And the way that it's used in these belts is very, very clever. Essentially, we've got 8 or so special carbon fibre cords that are all in the same direction. And that means that under tension, they're really stiff and really strong, so they can transfer huge amounts of power, even in this small, narrow package. And then, well, just look, we've got no dangly bits at the back. And also we've got, well, just effectively one moving part. So that means that all the grit, all the grime, all the mud, well, it's not really affecting anything. With less moving parts, well, comes a lot of benefits. Unlike a chain where we've got to have exactly the right amount of lube, because too much can cause attraction of dirt, and then if we've got old stuff on there, we've got to change it, which breaks into this cycle of, well, degreasing and cleaning. We don't need to do anything with this. We can just rinse it down with water. And I can hear what you're saying at the back. We're not all single speeders, and that's true. Initially, belt drives were great for hub gears and, well, single speeds, because, well, they're very low maintenance and it doesn't shift. It's lighter, it's cleaner, it's quieter, and it keeps working in the dirt. While visually it's much simpler than a chain without all those links and side plates and pins, fewer moving parts translates into ultra low maintenance. There's no links to lube, there's no links to degrease and re-lube. With a very specific, just the right amount of lubrication, these belt drives just keep working through the dust, through the mud, through the crud. And thanks to those special drive sprockets, it's actually self-cleaning. So in that regard, it's the very opposite of a chain drive. As we've touched on, it is much lighter than a chain. And yes, I can hear you at the back that we don't all ride single speeds. And it is true, for a long time the best option beyond single speeds were hub gears from the likes of Shimano and Roloff. And now there's a swelling rank of gearboxes that not only offer impressive weatherproofing, the other big advantage that it opens up is a world of possibility with frame design, many of which move the mass of those gears to the centre of the bike. That offers up a better balance of weight distribution, especially on full suspension bikes. There's a benefit to that weight distribution changing because it also boosts the ratio between the sprung and unsprung mass. Unsprung mass is anything that has to move extremely quickly with the terrain. So for the rear wheel, it's components like the tyres, the wheels, the rear sprocket, the rear cassette or derailleur, or the belt or chain, and the rear suspension components themselves too. And finally, as we've got a single, perfectly tensioned belt, rather than a sometimes not tensioned, flailing chain, we don't have that metal on metal or metal on carbon clank that can not only eat away at chainstays, but can also drive even the fastest of racers to distraction. In short, belts are silky smooth and stealthy quiet. Now you might be thinking that these belt drive things are all very new and untested and untried. That isn't the case. They're actually much older than you might imagine. We're going to catch up with Chris Sugai, who is the Director of Mobility here at Gates.
Gates, was founded in 1911 right here in Denver, Colorado. They invented the V-belt and started supplying those to Henry Ford, I believe. We have 15,000 employees on a global scale, 120 different locations, and we're in 30 different countries. Today, we're known more as a belt and a hose provider. So we work heavily in anything that moves fluid from one place to another or power transmission. You can't really go through your day without interacting with the Gates product, unbeknownst to yourself. So, your coffee maker might have a Gates belt. If you get to an elevator, the doors would open with a Gates belt. You get in your car, the fluid be pushed around through a Gates hose, and maybe you have one of our belts installed in the car. When you get to an ATM machine, the little feeder that your money comes out, those are little Gates belts that we make. If you go up to a cash register, the thing that pops the drawer open is run by a Gates belt. So anyways, it is kind of, it's interesting as you go through your day that you would interact with one of our products one way or another.
Safety first here at Gates. That's because I've got to lift a really heavy belt, except the belt's really light. But this can't transfer that much power, can it, surely?
Actually, this synchronous belt uses a polyurethane body with a carbon fiber tensile cord and has a tremendous amount of power transmission capability. So much so that it can transmit the same amount of power as that chain behind you.
Wow, that's really impressive. And I think that's why I've got the gloves on is, well, not only that I might trap a finger under here, but also because, well, it's going to be greasy. It's going to be messy, isn't it? Oh, shivers, that's heavy. Oh, my God. Yeah, that is ridiculously heavy. Well, and it's got so many moving parts. We've got rollers, we've got pins, we've got locking plates.
With all those moving parts, those metal on metal parts, you have to have lubrication in there to keep it working properly. That lubrication can attract dirt, debris, and actually cause wear and reduce or require you to replace the parts more often. A belt actually doesn't require lubrication, and we don't actually recommend lubrication. It doesn't use it, and it would actually cause debris and everything to get in there. It's actually zero maintenance.
I'm told this is a Cummins diesel engine, which for some people out there will get them really G'd up and excited. But here's another application of a belt. This one's different again. This is a Micro V. It's got a tensioner as well, so it's slightly different again. And this is using the engine power to, well, run the alternator and, well, charge stuff up. And it shows that there's this broad application of differences in belts. So highlights that Gates, started off with one type of belt, but they've moved through lots of different iterations for lots of different applications. This one is automotive, but it's not transferring that much power. We've got another belt that does. This one is a dedicated nitro belt. You might be wondering what that's for, and it's for, well, wild, high-power drag racers. So these are cars that are taking under 5 seconds to a quarter of a mile, and they've got lots and lots of power. And this belt is dedicated for, well, the superchargers. This is super power transfer just in my hands. It's ridiculously light too.
During the period of time I've been here, I've learned so much about how actually tricky it is to make these belts, because it's not a mechanical thing where you're machining things to a certain tolerance. And if you have the CAD design, you can repeat it over and over and over again. This is much more like chemistry. When you're working with rubber and synthetics, it's like baking a cake. So temperature and humidity and the chemicals that you're using to make the processes and the way the machines are run are all part of the secret sauce that makes our belts. And it's a lot of internal knowledge that we've gathered over the decades.
We have a lot of experience of, the customer needs. Some of the applications like in agriculture and so forth, these, dirt, there's a lot of dirt and dust. Now when we start moving to the bicycle side, same type of environment, right?
I think lots of people might think, oh, you're new to bikes, but you're not. You've been doing it since around 2007, haven't you?
That's correct, yeah. We had our first system started in 2007, released it at Interbike in 2007, and since then we've been hard at work creating a bunch of different types of products for different applications. We actually have 4 distinct product lines for bicycles specifically.
You've seen our belts on the World Cup bikes. But we really have a trickle-down technology that goes all the way down through a line that makes our systems accessible to not only the kind of the tip of the spear, these World Cup mountain bikes, but also your everyday commuters, which are more mainstream.
Looks like you've gone on a really big journey across a full range of not just mountain bikes, but commuter bikes and e-commuter bikes, and quite specific, I guess, e-bikes that are using hub gears versus mid-drive motors. What's the story about this process?
That's correct. So we started with single-speed mountain bikes, figuring that if we could compete at the hardest application we could think of, that we could do anything. Quickly then, we actually moved on to commuter bikes. From there, e-bikes kind of hit. And so we had to have a lower entry-level cost for mid-tier e-bikes. So we created our CDC line specifically for that. And now, hub motors are all the craze again. And so we actually have a separate product line that covers hub motors specifically as well, and the lower entry price points for those. But what we're really excited about is our re-entry into mainstream mountain biking.
We headed on to the Customer Solutions Centre. Hi, Chris.
Good to see you.
Yeah, thank you. So this is the bike shop or bike lab?
This is the bike lab for Gates Belt Drive. This is where we have a number of our bicycle fleets, our technologies, some of our new parts that have come in for qualification and validation, as well as a regular bike shop and customer service and technical support.
Awesome. So can you describe your role here in the bike lab and here at Gates?
Absolutely. I'm responsible for global business development for the bicycle business. So that has kind of 2 legs we stand on. One is our OEM sales group, which is working with our customers, which are OEMs, brands you would recognize, to make sure that we know what's coming the next year or 2 in their product lines. We're taking our current portfolio of products, making sure that there is a fit so that they can spec early on and be ready for production. So that's a customer viewpoint. The other viewpoint is more strategic partnerships. And so we have an advanced development team that is working with all of the various drivetrain companies. I like to say at Gates, we connect what's going on at the middle of the bike to the back of the bike. And there's a whole lot of things that are developing in that space. Your traditional mid-motors, your traditional internal gear hubs, but now a lot of the integration like Pinion MGU with geared mid-motor and gearing at the middle of the bike, which opens up e-mountain bike space for us. So we really have to be aware and have our finger on the pulse of those strategic partners, what they're working on 2 to 5 years in the future, so that we are in their ear, they know and the intricacies of belt drive, that they're ensuring compatibility with a number of the drivetrain systems they may not know about, as well as making sure there's no interference or any other issues with belt drive, so that we're ready with a product portfolio right when they launch.
So how can you help customers, and we're talking about OEM customers, choose and use the right materials?
Yeah, it's a really good question. We have here are a couple of workstations, and here we'll handle all of the technical support or custom support needs from the Americas primarily. But what we have, one particular tool we've launched recently is what's called the Bicycle Drive Assistant. And so this is an application that leverages some of Gates' historical tools, but actually does a bicycle-specific application.
Okay, cool. Because you've got similar tools for all the other belts that you make for all the other industries, from top fuel dragsters to combine harvesters.
Correct.
Okay, Got you.
The difference is bicycle is very modular, right? There are only a certain number of mid-drive systems. There are only a certain number of internal gear hubs.
Yeah, yeah.
So we're able to take all of that information from our strategic partners, put it into one particular system in a database that leverages all of that information, and we can even use some customer information. If there's a sprocket ratio limit for one of our internal gear hubs, we won't allow the customer to spec something that will violate that internal gear hub requirement. And so it's a really useful tool to help customers not only gear their belt drive bicycles specifically correctly, it helps them with e-bikes and whether it's a speed pedelec or a normal 25 kph pedelec, but as well will help them avoid some of the pitfalls of trying to design something with the wrong components.
Okay. So are these just all yours? As in, not your personal bikes, but Gates in general?
These are owned by Gates. We do have, this is just a portion of our fleet, to be honest.
Okay.
There's a number of urban bikes that you can find in here, both value e-bikes, down into below $1,000 up to 2,500, which is kind of our value e-bike segment. We've got premium e-bikes like most people are familiar with in Europe. We've got quite a few mountain bikes now with gearbox applications and e-mountain bikes. And so we have a fleet of bikes. We do several types of events in North America. Sometimes it's more commuter focused. More recently, we've been doing a lot of mountain bike focus. About 3 years ago, it was really interesting. 3 or 4 years ago, we show up at our first demo event and people run to all the other bikes and we're here waiting for people that come by and ask, and they come in and they say, what is this? It's a gearbox. Oh, a gearbox, how does it work? They didn't really know much about the technology that's been in Europe for over a decade. So we have this discussion, and then we have some other unique initiatives, and what you've seen over the last 3 years is now our belt drive bikes are the bikes that people run to first.
Oh, wow.
They know about belt drive. They know about gearbox. They've seen the UCI World Cup footage. They really understand the benefits of lower unsprung mass, and they want to experience it themselves. So it's been a big shift over 3 years, and that's just getting out there, getting with the end consumers and helping educate. This is a lot of parts. There are some race that we use, but a lot of this is actual first run of production components where we get a pilot run in, or sometimes we call a PPAP run. We want to make sure we get a certain number of parts run so the consistency is there.
Okay.
Then we do all of the measurements. Each of these products has a unique interface that it has to mount to at the middle of the bike, or a unique interface at the back of the bike. And so a lot of what you see here is, a variety of front sprockets, a variety of rear sprockets. Traditionally, those are big fronts and small rears, right? But when you look at pinion or other gearboxes, sometimes they're very similar size. We call it middle size. And some drivetrains that are coming out are opposite. They'll have a small front and a large rear. So there's a lot of technology development going on in there. And what we have here is a stock that we can send out to strategic partners that need to test our belt drive systems with their new drivetrains, or getting these samples to OEMs worldwide that want to be able to get them, do their final spec and checks for assembly, and then they purchase through the normal channels.
Okay, before we go, I spy something which we have to see, which is the Intense M1, which we've got a gearbox, we've got belt drive, and we've got a tension on it. So can we have a look at that?
This is an exciting project. It came about really, really fast, to be honest. And honestly, when they launched the M1, a little inside information, I remember seeing the design for it and seeing how it was perfectly suited for a gearbox. And I texted the head of Pinion to say, hey, how cool would it be to get a Pinion gearbox inside of this particular drivetrain,
okay, nice.
Knowing that we were already pushing through with Gamux.
Yeah.
And so it's definitely a unique design that really allowed for the gearbox to fit. We worked closely with the team to develop a tensioner aspect that will fit and idler components, and so it's a really beautiful, beautiful kit.
Yeah, and so with the race team, you talked about how you were there at the start, effectively, this whole wonderful world. I've chatted to Jeff about his input to it, and then we've chatted at races to kind of Millie and to Joe. But you're here getting feedback, I guess, from those races. And is that like a regular occurrence that they're, I guess, phoning in here with like tidbits of info?
It really is. I'll say that there's been good feedback. We've had some really sloppy races, some really dusty races.
Yeah.
Some stuff that makes you a bit nervous when you're seeing your baby go through some of this torture. The feedback has been mostly all positive. Really few issues. If anything, it's been about, can we get slightly different gearing? Can we work with the gearbox to get slightly different gearing? Can we do a smaller sprocket? So we've done 2 different smaller pinion front sprockets that are not products that we can sell right now to customers, but is specific for racing. Because racing, we can really test it out and prove it out to the unique attributes of downhill racing. So it's been really collaborative and building on the initial offering with additional products, and nothing really that's like, oh, we really have to go back and retool this. It's not meeting the need. It is meeting the need.
One thing that I saw at lots of bike shows, from Taipei to Sea Otter to Eurobike, was that so many more bikes now have got belts on. And I think it's really interesting that the belt drive technology feels like it's been there and been proven on those cyclocross bikes and on those single speed bikes. And now it's really coming into fruition with this change in terms of, well, gearboxes. Do you think that's the real driving force? That's the next step to take over? Because I think it feels like it's proven that the belt drive can be so much more like easier to live with on a mountain bike. Like it's living in the dirt, and it's in a great space to do that versus a chain with so many pivot points. But do you think the gearboxes are the next big thing to help drive it forward?
Absolutely. Walking around Eurobike, you would have seen a lot of commuter bikes and higher-end e-bikes with belt on them. In fact, you would find one in almost every booth. But what you don't see a lot of is the mountain bikes and e-mountain bikes. And that's because the shifting technology just wasn't ideal for mountain bikes. With the increase of gearbox technology, having electronic shifting and things like geared mid motors, the space is blown wide open for the opportunity to actually run a belt and not be limited to a single speed. So yeah, with that technology, I expect to see a whole lot more belt drive, because the benefits are there. You still have the reduced maintenance, the longer life, and the quietness that the belt provides that chains just don't have.
Racing is still at the heart of how you're like pushing forward with the development. Can we talk a little bit about how you've pushed into that segment as well?
Absolutely, yeah. So this is actually the third year in a row now that we have been running downhill bikes with belts. If you guys are not familiar with it, we have 100,000 euros out there as a prize purse.
Gates is running a 100k belted purse with a 100,000 euro prize purse for the first elite racer, men or women, to win a World Cup downhill. Talk about putting your money where your mouth is. The prize has really injected lots more innovation. We've seen not just one team or two teams, we've now got 4 teams pushing the limits of downhill. We've got new prototype bikes, we've got lots of riders trying to win this 100k. I don't have 100k to give away, but if I was, I'd want to be really sure that my product was, well, up to the potential of this huge prize purse that we've talked about before. And, well, actually, Gates are the same. They do a huge amount of testing. As we've talked about, their business isn't just belt drives. They do hoses too. And it's not just small belts. They do huge belts, and they do a massive variety of different applications. And part of all of those different applications is a supreme amount of testing in really harsh lab conditions and race testing. But we're going to go to the lab to see how they test these to other standards. We're here at the Gates Technical Centre in Rochester Hills. This is their technical test facility. We're going to find out how they put their belts to the test. This test facility is vast. It is really huge. And this section is, well, effectively just the post room. This is where they're registering all the parts that are coming in to get tested. The test facility itself starts this way, and it's really incredible. Test facilities and testing is something that loads of bike brands do because quality control is important. All of the materials that are being tested are here, and this is one of the torture chambers in here for lots of products, belts included. There's corrosion, there's sand tests, there's mud tests. There's a whole gamut of different machines running huge cycles to make sure that the belts stand up in all these different conditions. Remember, we saw how they're used on tractors and agricultural parts. That test facility is still going. Then we've got, well, effectively like a forensics lab. The first thing you might see as you kind of have a little sneaky peek in there is that there's lots of dry ice, there's nitrogen, ultra low temperature, and that's because they've got ultra sensitive measuring devices from microscopes that can see cells and lots of high-end stuff. In here, there's acoustic testing. Now, you might think, well, why do I need to know if they sound good or not? No, it's not if they sound good or not. This is to know if a belt is making a noise and, well, if it's damaging, if it's running correctly, and how that might impact it. We've got an engineering facility where you can look at the data, 3D printers, special engine setups, just keeps going and going and going. They don't mess around with testing here. With a lot of bike brands, there's always a bit of the workshop that's maybe a bit messy, where there's some actual machining happening or someone with a lathe. Well, in a kind of typical way, Gates go above and beyond. So for all the testing machines that we've seen, well, they're making a lot of the fittings, they're machining lots of the parts, and they're doing them in this incredible workshop, this incredible machine shop that's got 2 CNC machines, it's got 2 lathes, it's got milling machines, and as you haven't guessed already, it is massive. It is really impressive. I've got to say, I've seen lots of bike factories, I've seen lots of facilities that designing and developing bikes, but just this workshop is actually bigger. And then, well, then we go to the garage, which is pretty huge. But that makes sense. Gates isn't just making bike bits. They're making bits for ATVs, they're making bits for tractors, they're making bits for combine harvesters, big stuff. And that means you've got to have a really big garage too. Then we've then got the weld station. And the welding area is so well equipped it can weld any metal. That in itself is pretty impressive. But Gates are always progressing. And the next thing they've got is a brand new dedicated bike space. Let's go and have a look. The epoxy on the floor is only just drying, hence why we've only got one tool station set up, of course equipped with Park Tool, and we've got this wonderful stand. Whilst the genesis and core of the bike business has always been in Colorado, Gates continues to add new stakeholders globally. And as we all know, bikes are contagious. This is going to be the hub for loads of bike development here at Gates. I think that's really exciting. It shows the level of commitment and the excitement here within this huge corporation of Gates that they're going to do big stuff in bikes. Behind me is the durability lab, at least some of it, because it is a huge space. And there's lots of machines that are running, doing lots and lots and lots of longevity testing. One of the tests we're going to see is a misalignment test, where on purpose, Gates have moved one of the cogs out of the alignment. They've got quite a strict protocol. So if you're building a bike, there's parameters that you need to build in. That's kind of quite normal. But what happens when you go outside those parameters? Well, we're going to go in this noisy space and find out. This is a really fascinating machine. We're doing an ISO test actually on the sprocket, but you can see that there's a belt on there. So it's loading that sprocket up about 4 times a second, sort of unloading and then loading it to replicate what you might experience. Another big chunky test machine. This one is doing something different. It's clamped one tooth off the belt and it's oscillating, well, very, very quickly, about 20 times a second. You almost can't see it, but it is happening. Well, I'm told it's happening and I can feel a vague vibration. And they're doing this shear test to see, well, if there's any changes and how long it can last. Because all of this testing to see how long things can last, really important for lots of these industrial belts. An environment chamber, or a type of one at least. It can go really warm and it can go really cold as well. And this one's designed to test belt tensioners, which are a really important part of Gates' industry in the automotive sector. Well, automotive has a really high level of testing. We talk about standards in the mountain bike industry, and some of the standards are there. There's ISO testing and there's other standards, but it's not as controlled. It's not like automotive where it's so critical. And this shows the depth of testing that Gates actually has on hand already. Again, a lot of testing might seem abstract, but it's really important. It's really important that they've got all of the data to back it up as well, versus, it just snapped at a certain weight. They need to know when it can snap, because that can tailor service life. And for lots of different products in the Gates range, that can be really important. This is a little dog bones. This is a standard testing device. Effectively, we've got fatter bits at either end so that it can be clamped and apply a set force, very precise force. And then the testing of all the strain and stretching, that happens in this little bit here. So the random mud in my hand, it's controlled mud as well, and it's sprayed on in a very particular way. And we can't be in the room because there's exceptionally loud motors running. But essentially, we've got this really gritty, grimy paste. As I said, a chain's worst nightmare. And that's sprayed on to the belt and the sprocket in an accelerated wear pattern. In terms of numbers, it's really difficult to give, much like with other transmissions or power transfer systems, a defined, this will last for every rider this long. Why? Well, every rider rides differently. The terrain they're on, the geography, the mud that they're in is going to be different. But what Gates are able to do is, even with this horrible mud, is say that realistically it's going to be over 3 times as long to wear out a belt and sprocket assembly versus the classic metal chain. At the start of the video, I framed this as, well, unchaining the status quo of mountain bike transmissions. And do I really think it's going to unchain? Is it going to unseat what we've got with drivetrains at the moment? I think it very much could. Gates is a fascinating business. It's very, very big, not just by a number of employees, but the broad industries that it's in. The application of where it's using its belts and all the different types of belts is staggering. There's so many different applications, and lots of them are in really critical industries where failure isn't an option. And I think that's a really important thing. We've not seen the level of testing in mountain biking or in the bike industry to this level before. And I think that means that, well, the technology is proven. The next thing that I think is really, really exciting is the way that they're working with the industry to see 5 years ahead or 2 or 3 years ahead to make sure that their product is in the minds of all these product developers. And that's really important because now we've got so many different drivetrain options in terms of gearboxes and different hub gear offerings. Well, this could very well be the future of mountain bike drivetrains. So, can this be the future of mountain bike power transfer? I think it really could be. It's going to be really exciting to see how many more bikes in the future are going to have this belt drive system on them.